Welcome to my channel, folks. In today's video, we are going to see how we can use AWS Lambda functions. The most foremost thing that I would like to talk about is you can write your code in a wide variety of languages in AWS Lambda. Currently, it supports Python 2.7, Python 3.6, and different versions of Node.js, Java, and C Sharp. In addition to that, Amazon has recently introduced support for Go language as well. If this is not enough, and if you have some on-premise custom binaries that you would like to run in AWS Lambda, that is also possible. You can bring your own libraries, the native ones, which might be even proprietary or which is completely written by you and nothing is shared anywhere. Still, they can be run in AWS Lambda. And how we are going to write all this code or how you bring this code, Amazon provides AWS Cloud9 service. It is an integrated development environment and it is available for you in the free tier as well. So you can go ahead and write your functions using the Cloud9 service, or you can write it offline, zip it up and upload it to your S3 bucket and consume it in your Lambda service. If that is not enough, for people who are familiar with Eclipse or Visual Studio, there are plugins available so that you can write your functions in your familiar environment and push it to AWS Lambda. So the people who are saying that I would like to do it everything in the CLI, yes, that is also supported when you're talking about AWS Lambda. The resource model is quite flexible in my opinion. It is like a dial-up rating. You can select from 128 MB of RAM all the way to 3 GB of RAM. The compute and the networking capabilities are allocated proportionately, and you are going to be billed only for the time that you are going to run your code. So you don't have to worry about provisioning it for more seconds. You can go ahead and say, I want to run my Lambda code for 300 seconds. And if that is sufficient, Lambda is going to finish that code in that time. And if that is not enough, you come back and say, I want a higher memory, and which will allocate your more capacity. And if you need it, you can go ahead and increase the seconds as well. And for all this, there are detailed metrics provided to you. We will see that in a short while what are the different metrics that Lambda provides so that you can optimize your runtime in AWS Lambda. Finally, who you are going to allow to trigger your Lambda, or what permissions you want to have a Lambda to have, that is absolutely to your flexibility. You can use IAM roles and you can control whether your Lambda runs inside your VPC or outside your VPC. So this way you can ensure that your Lambda functions are really secure and you're not leaking any information when you're executing code in the cloud. The other flexible usage that Amazon provides is you can trigger your Lambda functions by having synchronous events or even asynchronous events. And the events can come in any different size and shape. It can be from an EC2 instance changing its state, or DynamoDB tables getting updated, or S3 buckets having modification to its objects. Since there are multiple services integrated and new services coming online, you can build a whole new serverless architecture in the cloud using AWS Lambda. Finally, remember that AWS Lambda functions are stateless, and by definition, there is no affinity to the underlying hardware. So that means that you will have to store the state of your functions outside your Lambda functions. This allows Lambda to scale to any number of events without the impact on underlying hardware. That doesn't mean that your functions cannot have any state at all. You can configure state by storing the data in service like Elasticache, RDS, or any other relational database or database services provided by Amazon, or you can use a simple file storage that is in S3 also. It's up to you, but remember that you cannot have state inside the function, because once the function in runtime environment gets completed, you lose access to that data that was stored there. Finally, when you're talking about monitoring and logging your Lambda functions, you have a lot of metrics provided to you by default. Metrics like requests, the errors, and what is the latency in your Lambda function, and throttles. These are just some of them, but there are more available to you. If this is not enough, Amazon also has detailed logs provided to you through the CloudWatch service. It is possible to stream and centralize your logs so that you can analyze them in real time in other services like Splunk or Datadog or any of your favorite log processing systems. If that is not enough, you can configure X-Ray to go in detail into your logs and identify what exactly is causing the performance issues or what actions are being triggered by your Lambda function. In short, your Lambda architecture looks something like this. You will have an event source, which can be any of those different triggers that provided by Amazon, or it can be an HTTP endpoint through your API gateway. That is also possible. This event source is going to hit your Lambda function, which is run in different operating systems or different languages. And once the Lambda function processes the information, it can store it in a database service, or it can go ahead and hit another Lambda function or any other application service for downstream processing. So this is how Lambda works in AWS. In the next video, we are going to see how we are going to install and configure our serverless framework so we can go ahead and configure Lambda functions. See you in the next video. Thanks for watching. Happy learning.